We're also to evaluate the given double integral over the region D, where the region D is given here, where D equals the quantity x squared plus y squared less than or equal to 9, and our function f of x comma y is equal to 7. Let's first focus on the region of integration. We know that the quantity x squared plus y squared equals 9 would be a circle in the xy plane centered at 0 with a radius of 3, which is shown here in red. And because we have the quantity x squared plus y squared less than or equal to 9, the circle in the area in the circle is the region of integration. And next, because our function f of x comma y is non-negative over this region, this double integral is going to give us the volume under the surface above the xy plane over the region D. So if we look at this graphically, f of x comma y is the plane graphed in blue, the xy plane is graphed in yellow, and we can see the region of integration is this region here looking down on the xy plane. So notice how the volume under the surface above the xy plane over this region is a right circular cylinder, which means we could evaluate the double integral using the volume formula, volume equals pi r squared times h, which we'll do after we evaluate the double integral using polar coordinates. When converting to polar coordinates, it's important to remember that our function f of x comma y must be written as a function of r and theta, or f of r comma theta, using these formulas here, and then differential a, which is dx dy or dy dx in rectangular form, is equal to r dr d theta in polar form. So we have this extra factor of r when converting from rectangular to polar form. So starting with the given double integral, where we're integrating over the region D of f of x comma y, which is equal to 7, and then we have dx dy. In polar form, we'll have the double integral of, now for f of r comma theta, because f of x comma y doesn't have any x's or y's, f of r comma theta is still going to be 7, but then we have r dr d theta. Now we need to find new limits of integration for r and then theta. So looking at the region of integration, notice how r would start at 0 and go out to 3. So limits of integration for r are from 0 to 3. And then to trace out this area, we have to rotate one full revolution, which means theta would be from 0 to 2 pi radians. Now we first integrate with respect to r, so the antiderivative would be 7 times r squared divided by 2, or just 7 halves r squared. So when r is 3, we'd have 7 halves times the quantity 3 squared, minus when r is 0, of course we have 0 squared. So notice how here we just have 7 halves times 9, which is 63 halves. Let's go ahead and factor that out. So we'd have 63 halves times the integral from 0 to 2 pi of just d theta, if we want 1 d theta. So we'd have 63 halves times the antiderivative of 1 with respect to theta would just be theta. So we have 63 times the quantity, we'd have 2 pi minus 0. Well, 63 halves times 2 pi, or if we want 2 pi over 1, simplifies to just 63 pi. In this decimal approximation, this would be approximately 197.9203. Again, let's also check this by determining the volume of the right circular cylinder using a geometric formula. Where notice how the height of the right circular cylinder would be 7, because our function is f of x comma y equals 7, and because the region of integration is x squared plus y squared less than or equal to 9, we should recognize the radius r is going to be 3. So because the volume formula for a right circular cylinder is equal to pi r squared h, or the area of the base times the height, again we have h equals 7 and r equals 3, we'd have the volume is equal to pi times 3 squared times 7, which does give us the same result of 63 pi. Again, this would be cubic units. So in most cases, we won't be able to use a geometric formula to check our work, but in this case we can. Again, we just found the volume of the right circular cylinder below the blue plane and above the xy plane graphed in yellow over the region of integration, which was x squared plus y squared less than or equal to 9. I hope you found this helpful.